Okay, welcome back to another exam walkthrough. We're going to be doing October 2025, question number 20. We've got part A and we've got part B. So I want you to pause the video, do the question. If you want to go for the mark scheme, you can go to the end of the video. And without further ado, I want you to read the question. I'm not going to take some time to read the question, which I do in some other videos. So just read the question and I'm going to start answering. So in part A, they tell us, so we've got a section of bridge and we've got a pivot, and they're asking us for part A, state what is meant by the principle of moment. So the answer for this part is going to be that in equilibrium, the resultant moment is going to be equals to 0. So in part B, it says to raise a section of the bridge, a motor applies a moment about the pivot. The diagram shows a section of the bridge being raised. So we have the pivot right over here. We have the center of gravity of section of bridge, and then it's saying to us, explain the direction of the moment about the pivot caused by the motor as the section is raised. Now we can see here that the weight of the section of the bridge causes a clockwise moment, so the motor must cause an anti-clockwise moment. So this is going to be your answer. The weight of the section of bridge causes a clockwise moment about the pivot, so the motor must cause an anti-clockwise moment about the pivot. So this tells us the direction of the moment about the pivot caused by the motor, which is going to be anti-clockwise. You get 1 mark for this, and you get 1 mark for mentioning this. That's going to be your 2 marks. Now in part II, they tell us each section of the bridge has a heavy counterweight. Now counterweight, if we have studied this in class as well, counterweight causes a counterclockwise moment or an anti-clockwise moment. So counterweight causes a anti-clockwise moment. There's a clockwise moment due to the weight of the bridge, section of the bridge. So I just want you to keep that in mind. That's going to help us answer the question. And then it says, explain how adding the counterweight affects the work done by the motor to raise the section of the bridge. So I want you to know before, the moment due to the motor should be equals to the moment, or equals to, should be greater than the moment due to the weight, because the reason it has to be greater is because we're lifting the bridge up. So the moment due to the motor had to be greater than moment due to the weight. Now what's going to happen is that, remember, this is anti-clockwise, this is clockwise. Now we're going to have moment due to motor plus moment due to counterweight should be greater than moment due to weight. Okay, so basically what I'm trying to say here is that the moment that we need for the motor is going to go down because we're getting help from the counterweight. Since counterweight is coming in and we're adding that value, so 2 things are being added over here, so it's going to help our motor. Okay, so maybe before our motor needed a lot more moment, but now it needs a little less moment because counterweight is adding that extra moment that we need, since both of them are in the anti-clockwise direction. That's the major thing you have to understand. Okay? So your answer is going to look something like this. The counterweight causes an anti-clockwise moment. The moment due to the motor becomes smaller now because we have an extra anti-clockwise moment that's going to be coming from the counterweight. So the moment goes down, the force goes down, the perpendicular distance from the pivot remains the same. And then the force required decreases. Okay, so force required decreases for a given distance traveled x. So the force required to move a distance x decreases, and we can say that the work done to move a given distance x is equals to F times the distance x, and the distance x remains constant, so we can say work done decreases, and we already know the force decreases. So because of the force decreasing, the work done goes down, and then we have the final answer, the work done by the motor. Let me just write that, work done by the motor decreases, right? So work done decreases by the motor, and that's going to be your answer. So you get 1 mark for this, you get 1 mark for this, and then I think you get 1 mark for this as well. So these are going to be your mark distribution. You do not get a mark for mentioning this, but I still wrote it down because I think it's an important point. So yeah, so that's the answer to this question. A little bit tricky. You have to connect the concepts of work done and then the moment, and you have to bring them together. So I hope this was clear. And now we'll move on to the final part of this question, which is going to be a calculation for 4 marks. There's a lot of information here as well. So it says the section of the bridge is uniform. That's a key word. We have seen this word a lot in past papers, uniform. And the pivot is 12 meters from one end of the section of the bridge and 33 meters from the other end of the section of the bridge. The perpendicular distance from the center of gravity of the counterweight to the pivot is going to be 11 meters. Okay. The bus was moving across Tower Bridge when the motor began to raise the section of the bridge. When the center of gravity of the bus was 28 meters from the pivot, so the center of gravity of the bus, so this is the bus, it was 28 meters from the pivot, the section of the bridge was in equilibrium. The resultant moment is equal to 0. And then it says to us, determine the magnitude of the moment produced by the motor on this section of the bridge. And then they've given us the weight of the bus, the weight of the section of bridge. I'm going to talk about this a little bit more. And they've given us the weight of the counterweight. So I know there are 2 things here. There is the counterweight. We know the distance from the pivot. We know the force. We have the bus. We know the weight of the bus and we know the distance from the pivot. But there's one thing they have not given you in this question. They've not labeled it on the diagram, but they have labeled it before, and that's the center of gravity of the section of bridge. And we know the center of gravity of the section of the bridge, since the section of the bridge is uniform, okay, that would mean that the center of gravity or the weight of section of bridge will act from right at the middle. Okay, so we need to find these 2 distances right over here. Let's find these 2 distances. So we're going to do 33 plus 12. We're going to get 45. Divide that by 2, you get 22.5. So this is going to be 22.5 and this is going to be 22.5. Now we need the distance from the pivot. So we need this distance right over here. So I'm going to do 22.5. 22.5 minus 12 is going to be 10.5 meters. That's going to be my distance from the pivot to the weight of the section of the bridge. Okay, so I've plugged in everything and arranged everything there as well. And now we can just use the principle of moments. And the question is just to determine the magnitude of the moment produced by the motor. Okay, so magnitude of the moment produced by the motor. So that's all we have to calculate. So let's see each of them one by one and see which is clockwise and which is counterclockwise or anti-clockwise. So this is going to be anti-clockwise. This force will produce a clockwise moment, and the force due to the bridge, or the bus, my bad, the bus will produce a clockwise moment. So we can say moment due to the weight of the bridge, so I'm going to write weight bridge, plus the moment due to the bus should be equal to the moment due to the counterweight, CW, let's just write it like that, plus the moment due to the motor. Okay, and then I can just move this to the other side so I can get the moment due to the motor, which is what I'm looking for in the question. So I've moved the moment due to the counterweight. Now I'm just going to plug in the values and get the answer. So I've plugged in all the values. Be careful with the 71 kilonewtons. Kilo is going to be times 10 to the power of 3. And after doing this, you should get an answer of 8.4 times 10 to the power of 7 Newton meter. So I hope this was clear. And now I'll show you the mark scheme and then we'll end the video.